techniques and the opportunities and threats to European Union agriculture, organized by Farm Europe, a European think tank on agri policy issues. We have as the purpose, the objective of this webinar to foster the discussion on new genomic techniques, how they should be regulated in the European Union, to have a better grasp on what they are and their potential, and also a better understanding on their use around the world. And I'm very glad to be in a position to present you an excellent group of panelists. We'll have three groups. First, we'll have an introduction by a member of the European Parliament, Ms. Irène Tolleret from the Renew Group, followed by a group of two presentations from the policy side, from the European Commission. We'll have Dr. Sabine Jülicher from DG SANTE, and then Mr. Tassos Haniotis from DG AGRI. Then in a third group, we'll have a presentation of the situation worldwide. We'll have the chief scientist of FAO, Dr. Ismahane Elouafi. She will make her presentation by video. Unfortunately, she cannot be with us at this time. Followed by Dr. Khayat from Israel. I'll present each of you more in detail when the time comes. And the last but not least of the groups is on science, to get a better understanding of what NGTs are. And we'll have Professor Dr. Klaus Dieter Jany and Dr. Georges Freyssinet. So I think we are absolutely ready to start. And I will turn now to Ms. Irène Tolleret. But just before doing that, let me remind you that at the end of the presentations, we'll have a question and answer session. You know how to do it. If you want to participate, you have a question and answer button in your screen. Please use it. And we'll use our time to have your questions and responses from the panelists. Now, Ms. Irène Tolleret, if I might turn to you to give us your introduction. We are still waiting for Ms. Tolleret to plug in. Let's just wait 1 minute.
Your microphone is off.
Oh, it's on, it's on. Oh, no, it's off, it's off.
It's off.
So, as I was saying, perhaps if we can just wait 1 minute for Ms. Irène Tolleret. I'm seeing that she's trying to connect.
Hello. Sorry, Mrs. Tolleret is trying to activate her microphone. She has some technical issues. Sorry.
No problem. We can wait. We want definitely to hear what she has to tell us. Ah,
Now it's fine.
Tolleret. Very welcome. Very nice to have you here with us. It's an honor to have you in this webinar on new genomic techniques. And we are very eager to have your views from the political side on these new promising techniques and how you see the political and policy situation in Europe. You have the floor, Mr. Tolleret. So,
hello?
yes,
You hear me?
we can hear you.
Sorry about that. There was a little problem. So, first of all, it's my turn to speak, is it?
Yes.
Okay. So, first of all, I would really like to thank Farm Europe for inviting me. I'm very honored to have the possibility to open this very interesting event. We are in the area of climate change. European farmers are facing serious challenges, not only due to market volatility, but also as a consequence of extreme weather conditions. The European Union has set out to lead the ecological transition, and this has become the main creed of its future economic transformation. This year, a severe frost has devastated the harvest in thousands of hectares of vineyards and fruit trees in some regions of the European Union. This situation is only an example of the seriousness of the climatic stress that farmers are facing. Due to this, we must also take into account the added pressure that producers have been enduring for years due to the strong imbalance in the food chain, which lead to a downward trend in the market. In addition to this, the European Union would like to achieve very ambitious targets of reducing chemicals in agriculture. This reduction may exacerbate the current shortage of active substances available to deal with epidemic. We must not forget that climate change is also accompanied by an increased risk of pests and new illnesses. It is therefore important that the Union equips itself with the means at its disposal to make this economic and environmental shift a reality. The agriculture of the future has to become more environmentally friendly, but it also has to remain profitable for European farmers. Otherwise, the sums will not add up and the European Union will be invaded by production from third countries with lower standards in terms of food safety and environmental protection. Currently, the CAP does not have effective instruments to protect farmers from extreme climatic phenomena. Agricultural insurance systems are not sufficiently reactive and they represent an increasing high cost for the producers. Persistent drought and the need to rationalize water consumption are also a serious concern for farmers. Nevertheless, I truly believe that the impact of climate change in the agricultural sector cannot be only addressed by improving the financial instruments to compensate farmers. I think that a solid preventive approach is necessary to nip the evil at its roots. New breeding techniques may be an efficient and even affordable solution to improve the resilience of European cultures to climate change. A large number of third countries are betting on them, and in the next 10 years, there may be hundreds of products issued from these new techniques in international markets. Many of those products would reach the plate of European consumers. Last April, the European Commission presented a report on the situation of new breeding techniques, which will precede the impact assessment and the legislative proposal. I welcome the good intentions of the European Commission, but I am afraid that in order to have a rational debate in the European Union on new breeding techniques, We must counteract the distrust of the public opinion for the scientific progress in the agri-food sector. For some NGOs, technological development in this sector is synonymous with intoxication. We are faced with a paradoxical situation. On one hand, we are all celebrate the discovery of new techniques, such as CRISPR-Cas9, which has received the Nobel Prize. But on the other hand, public opinion prevents science from improving our day-to-day life. The discussion about new breeding techniques raises important questions. Since many third countries do not hesitate to embark on this new technological path, some of us already fear the consequences of this inevitable evolution for European farmers. Would European producers be in a position to compete with their counterparts in third countries? Would other alternatives to deal with our environmental challenge, such as integrated pest management, be enough to guarantee food sovereignty? I do not support NBT at any price. I believe that these new techniques should guarantee the preservation of biodiversity, and farmers should have the freedom to choose other traditional solutions. Another question comes to my mind. How could the coexistence between conventional solutions and those emanating from new technological solutions be managed? Is it possible to avoid the negative impacts of patents on farmer rights in relation to the use of seeds? As the European Commission says in its April report, any further policy action should aim to reap the benefits of innovation while addressing concerns, and efforts should be made to reconcile opposing views in order to find common ground. I am looking forward to hearing your opinions about all those questions. I thank you very, very much, and very sorry for the delay in connecting because of the problem. Thank you very much, and have a very good meeting. I listen.
Thank you so much, Ms. Tolleret, and thank you again for participating from the European Parliament. We know you are very busy with the conclusion of the negotiations on the CAP reform. So again, thank you very much for finding the time to be with us. Now, if we can move to the next group of panelists, and I would welcome Dr. Sabine Jülicher. You are director in DG SANTE, responsible for the area of food and feed and innovation. And we are very eager that to share with you and share with us your presentation on the EC study, the European Commission study on the new genomic techniques. So you have the floor.
Yeah, thank you very much indeed. Good afternoon, everyone, and thank you for the possibility to speak here and to discuss, if possible. We have already heard, indeed, in the end of April, the European Commission published a study on new genomic techniques. That study was prepared on the request of the Council. And when we speak about new genomic techniques in the context of this study and in our discussion framing from the European Commission side, we use this term to refer to techniques of genome modification that have emerged since the current GMO legislation was adopted in the early 2000s. So techniques that have evolved in the last 20 years or so. Ms. Tolleret, she already alluded that the Commission has announced a policy action specifically on plants derived from certain of these techniques. But however, before I go into these details, I have an echo here. I hope this is not the case for everybody else. Before we go into these, into the policy action, I would really like to focus on the study, as really, in our view, it represents a snapshot of the current situation and can as well and should as well serve as a basis for the rational debate everybody is calling for. Thank you for the slide. Just to speak a few words about the context, all of you specifically here in this forum are aware of the European Court of Justice judgment of 2018, which clarified that the EU GMO legislation applies to products obtained with new mutagenesis techniques. The Council took note of that judgment, everybody else did so. And the Council noted that the court ruling on the one hand brought legal clarity, but it also raised practical questions with consequences for authorities in the member states, consequences for the union's industry, for research and many other sectors. That's why the Council requested this study from the European Commission. Next slide, please. In reply to this request, we wanted to provide clarity on NGTs in the form of an updated and comprehensive set of information, which really can be the basis and assist in deciding future policy action in this area. The study, as you may have seen, covers the use of NGTs in plants, in animals, in microorganisms, in various sectors such as the agri-food, the medicinal and the industrial sector. We also considered it important to take into account major policy objectives under the European Green Deal. Ms. Tolleret already alluded to those, which are very much related to climate, for example, but also under the Farm to Fork strategy related to sustainable production of food and sustainable food systems, but also strategies like the pharmaceutical strategy. So we were keen to make this link as well with the objectives of these major political initiatives. Next slide. Just a few words on the methodology. How did we elaborate that study? On the one hand, we had a targeted and very broad consultation. And the study includes the views of member states and relevant EU-level stakeholders that, on the one hand, could be impacted by NGTs or have in the past shown an interest in the topic. We had also support from the Commission's Joint Research Center, which supported the study with 2 state-of-the-art reviews on the scientific and the market landscape of NGTs. Very interesting reading, I have to say. The European Food Safety Authority provided an overview on the risk assessment of plants produced by NGTs based on its own and work of the national authorities. And we took into account expert opinions from the chief scientific advisors and the European Network of GMO Laboratories, as well as the European Group on Ethics in Science. Next slide. Well, the one after, thank you. I'm a bit, ashamed to explain what are NGTs, because we have here so eminent scientists. But indeed, I think it is very important that we get it clear in our mind what are we talking about, because new genomic techniques, they are a very diverse group of techniques, and they can be used in various ways to achieve different products, ranging from small changes in the genome to modifications that are far more extensive and multiple. And we have, here basically the definitions, which are also very important to keep in mind, because in the rational discussion that we are looking for, we really have to be clear, what are we talking about? Are we talking about changes without insertion of genetic material, or what type of modifications are we really talking about? What is clear that NGTs and their products have been rapidly developing in the last 2 decades, mainly outside the EU, and some applications, again, outside the EU, are already on the market or really close to the market. In the EU, there's really considerable interest for NGT-related research, and many Member states and stakeholders highlighted that the current regulatory framework has a negative impact on EU research and innovation. Next slide, please. There are indications of possible benefits and concerns associated to NGT products in their current and in their future applications. And when we just look at the agri-food sector, we see on this slide, and we know from many applications that are in development, that NGTs, for example, can make plants resistant to pests and diseases, which provides possibly an opportunity to use less pesticides, less chemical pesticides. There could be some answers with regards to climate change, with regards to the nutrient content on certain plants, and so on and so forth. Many of these traits are fit to contribute to the objectives of the European Green Deal and the Farm to Fork and biodiversity strategies, as well as to the Sustainable Development Goals of the United Nations. On the other hand, some stakeholders consider that these benefits are still hypothetical, that these are empty promises, and that they could also be achieved by other means. Next slide. There are concerns, and in view of the Commission, these have to be taken seriously. They relate to possible risk of these products. They relate to possible environmental impact of NGTs. There is a question about the coexistence with organic and GM-free agriculture. And there is a big demand for clear labeling provisions and consumers' right to information. Next slide, please. So on safety aspects, none of us will be surprised that there are diverse, sometimes opposite views. However, on some applications, there is considerable and solid scientific evidence. As I said before, we consulted EFSA specifically with regards to plants, and EFSA concluded that there are no new hazards specifically linked with targeted mutagenesis and cisgenesis in plants when we compare to conventional breeding. Also, EFSA concluded that unintended modifications of the genome with targeted mutagenesis are of the same type and fewer than those occurring with conventional non-GM breeding techniques. So that means, in simple terms, that in certain cases, plants obtained by these techniques might have the same safety profile as conventionally bred plants. In fairness, we have to say for other NGTs or for applications in animals and microorganisms, maybe the scientific knowledge is still limited or very limited, or in places lacking. Next slide, please. Other main findings, and I will be fast here, the study shows that there are implementation and enforcement challenges, in particular on foot of the court ruling, that there are certain legal uncertainties in the current GMO legislation. In several parts of the world, and we will hear that, I'm sure, regulatory frameworks have already been adapted to the specifics of NGTs. And for enforcement authorities in Europe, for operators and applicants, the detection and differentiation of NGT products remains a challenge. In particular, those products that do not contain foreign genetic material. In the study, you will find information on the opportunities that can be found for small and medium-sized enterprises. The study also covers the issue of patents. There is a discussion around, the benefits of patents, in promoting innovation. There are also critical views on that. We have information on the ethical concerns that are around, you know, on the one hand, missed opportunities, on the other hand, in particular applications in humans and in animals. So ethical concerns are raised. There is a very clear request for information and labeling, but there are also diametral opposite views who say we shouldn't label and we shouldn't inform on products that can't be distinguished from conventionally bred products. And there is a broad agreement that we need public dialogue, that we need more awareness, more information, and that the perception of, you know, what these techniques are, what they can bring, is a very important factor in our discussion. If I can go to the next slide, sorry. I would also think in terms of conclusions. We have what I just said, the implementation challenges and the uncertainties. They are very important in this context. There are strong indications that the framework is not fit for purpose for some NGTs, and that the framework needs adaptation to scientific and technological progress. There is the reflection that it may not be indicated to apply different levels of regulatory oversight to similar products with similar levels of risks, as this is currently the case for plants conventionally bred and obtained from certain NGTs. There's also reflections that the current risk assessment procedures are too rigid and they are difficult to adapt to scientific progress. The study noted that follow-up actions should consider if and how this adaptation should be provided in order for the legislation to be resilient, future-proofed, and uniformly applied, as well and how it can contribute to sustainability objectives. And any further policy action should aim at enabling NGT products to contribute to sustainability while addressing concerns. Next slide, please. The next one after. So the council requested, this is my last slide, the council requested the commission to submit a proposal, if appropriate, in view of the outcomes of the study, or otherwise inform the council on other measures required. The commission, on foot of this study and following the analysis that it carried out, believes that NGTs can contribute to the Green Deal and Farm to Fork objectives, that it can contribute to the objectives of innovation and sustainability of the food system, as well as to a much more competitive economy. And based on the outcome of the study, the Commission has concluded that there is sufficient evidence to initiate a policy action on plants derived from targeted mutagenesis and cisgenesis, so a certain spectrum of the NGTs. The policy action will aim at a proportionate regulatory oversight that maintains a high level of protection of human, animal health and the environment, while at the same time allow Europe to reap the benefits from innovation. In terms of next steps, the Commission will carry out an impact assessment. There will be a public consultation, and we will do, as we always do, examine various policy options and also the concerns that have been expressed in the context of the elaboration of this study. We are currently engaging in wide-ranging communication efforts. I think someone referred to the discussion in the council yesterday, but also, you know, with stakeholders, with members of the public, with the parliament, in all various fora. because what we really want to do is share the results of the study, discuss next steps with EU institutions and stakeholders. And with this, I would like to end my presentation and recommend the study as background for future discussion. Thank you.
Thank you, Dr. Jülicher, for your very clear presentation of the Commission study. Before I turn to Mr. Haniotis, let me just remind all the speakers that we are a bit short on time, so if they can restrict their presentations to a maximum of 7 minutes, I'll be very grateful. Now, turning to Anastasios Haniotis, Tassos, a good friend of more than 30 years, and now acting Deputy Director General in DG AGRI with a host of responsibilities there. Tassos, we are very keen to have your views on how agriculture see these promising new techniques.
Thank you very much, Joao. Well, you brought to my memory not only the over 30 years when we first met, but also the over 20 years when I was reporting to you in the beginning of this debate on what was happening on the US side when I was based in Washington. And some of the things that I will refer to relate to that. First of all, apologies to Sabine, the echo was mine, as for some reason everything seems not to be working in my computer. That's why I had to switch to tablet. So it was double entry. No, this is not DG AGRI sabotaging DG SANTE. Sabine, if somebody says that tomorrow, don't believe them. On the contrary, I fully support what you say, and I think you outlined very well the path that we need to follow to arrive at any decisions. So let me start first by identifying the priorities as we see them in agriculture, both in terms of where the common agricultural policy should be going, but also in terms of where the Farm to Fork and the Green Deal has brought us. When we talk about climate, what comes to mind? Drought, diseases, especially plant, but not in plant diseases, input use, and the need to adapt into use to this type of priorities, and output rates. What can we do in terms of the food we produce and the feed we produce to make it more climate friendly? In all of these areas, the role of science is essential. The role of science is not now essential, has always been essential, whatever level of knowledge and science we had over the centuries, because agriculture without changes in breeding, both plants and animals, simply doesn't exist. It's not that it wouldn't exist, it doesn't exist today because things are happening on the ground worldwide. What the current situation does is allow us to discuss the issues of plant health with a certain reference to what is happening in human health, because it's not only the role of science, but the acceptance of science and the challenges of science that seem to be pretty common right now. We have seen that very clearly in the debate about vaccines. Interestingly enough, two of those are ones that are coming from traditional techniques on biotechnology. And we have seen both how weighing the risks and benefits plays in people's choices, but also we have seen that inevitably there is always going to be resistance about the knowledge that is developed by science. And here it would be extremely important when we come to judging the next steps to base decisions on results that are solidly founded on analysis and what science provides in terms of perceptions. And I mention that because I come to the last point, because I prefer that others that are more expert in that come with questions or comments. It's the issues and the challenges that we have at stake. And what could new technologies, including those, do? First of all, we need to clarify that there is no such thing as a monopoly in best practices and in technologies. In the same conditions, a lot depends on what the managerial skills of farmers would like to do, what the existence of infrastructure from advisory system to internet would allow people to do, and also what the choices that people want and the link of the producer to the consumer would like to do. But whatever the situation is, at the supply side, there is a need to arrive at ways that reduce the increased costs in the agricultural production. Most of the discussions we're having are having the response that what you want us to do increases the short-term cost, which is correct. The important thing is to see what can reduce the marginal cost of production to allow us to arrive at addressing a problem that may not be European, but is a global one. We need to produce at the global level more with less. At the European level, we don't necessarily need to produce more. We might need to produce in a different way, but we need to be able to say and show whether we contribute to this global challenge or not. So the first thing that we have to focus, and that's where we see a very significant linkage of these new techniques, is on the contribution on the supply side. Second, there is also, so it's, if you want, the farm side, there's also the fork side. And on the demand side, it would be extremely important to focus on the acceptance of consumers with any means that are available. And sometimes this means start with a better communication on these technologies. I mentioned before that the debate as it started 20, 25 years ago when we were communicating with raw. And from that time, one of my major concerns is how in the world can some of the top science of in the world be so ignorant about history, because using the term genetic modification scared a lot of people. What we're talking about here is techniques that have similar processes, whether it's human health, animal health, or plant health, and they need to be addressed in the same way. And communicating this message would be extremely important in terms of realizing that the demand is not only a function of prices and quantities, it's a function of tastes and preferences are linked to perceptions. And we need to make sure that these preferences and perceptions are respected overall, but at the same time, the explanation about what are the real risks is split from what are the perceived risks. And we have seen also, and I bring once more the vaccination debate, that in the modern world, all sort of conspiracy theories can fly and generate impressions that are not based on anything. And finally, and last point, it's the farm to fork also has the two-part trade in the broader sense, the exchange of what is produced to what is consumed, both internally and internationally. And obviously in these developments, we need to be aware of what is happening in the rest of the world and how in these developments, Europe will be able to demonstrate its significant advantage when it comes to science and the production of science. And here, if you want one observation also from my time in Washington, there were too many Europeans that I have seen leading research in American universities, simply because there was a lot of resistance in Europe. I think it's about time that we change this trend and use the enormous human capital we have in Europe. Thank you very much.
Thank you, Tassos, for your very clear presentation of these issues. And now we turn to the second group of panelists. As I told you at the beginning, we have now a video presentation by Dr. Ismahane Elouafi. She is the chief scientist of FAO. So if we can share her video with all of the attendants.
Honorable members of the European Parliament, representative of the European Commission, it is an honor to address all of you today to discuss such an important topic. I would like to thank Farm Europe in particular for hosting this event. We are here today thanks to the European Commission initiative in the quest for evidence-based decision-making on new genomic technologies via the commissioning of this comprehensive report. In fact, the European Commission commissioned an earlier report in 2011 entitled New Plant Breeding Techniques, State of the Art and Prospect for Commercial Development. However, the science of genome editing changed dramatically with the invention of the CRISPR-Cas system in 2012, which has been recognized as the most efficient and most used genome editing system for plant and animal. The discovery of genome editing, including the technique based on CRISPR-Cas systems, resulted in the 2020 Nobel Prize in Chemistry being awarded to Dr. Emmanuel Charpentier and Dr. Jennifer Dunda. Genome editing techniques have been used in many ways to improve plant and animal population. Some of the example I would like to share with you, it's, for example, soybean that was edited to be high in oleic acid, which is very healthy. Cattles without horns, which is very good for the welfare of animals. And the third example from the fisheries, it's a farmed Atlantic salmons that are sterile and cannot breed with wild salmon. This versatility is indicative for breeding crop varieties or other animal varieties to improve their tolerance to abiotic stresses like drought, heat, salt, nutrient deficiencies, and their resistance to pests and diseases. Ladies and gentlemen, despite the rapid adoption of genome editing, its affordability and ease of application, the development of governing policies and legislation lag behind and big time. There is a lack of agreement as to whether genome-edited organisms are genetically modified or not, and subject to the Cartagena Protocol on Biosafety to the Convention on Biological Diversity. The Court of Justice of the European Union in 2018 ruled that the gene-edited crops, including those produced by the CRISPR-Cas, should be subject to the same regulation as conventional genetically modified organisms. The approach of the United States has been the exact opposite. The USDA has ruled that the genome-edited organisms are not subject to any additional regulation. The same approach was adopted by both China and Japan and many other countries. This EC study indicates that some of the new techniques create new challenges for the regulatory system, and that ensuring that legislation remains relevant, it's likely to be an ongoing challenge. While many high-income countries have been taking decisions on the subject, the continuing lack of international consensus and on the governance of these technologies is very negative, particularly for low and middle-income countries. FAO, as a neutral broker, can play a key role by providing robust science-based evidence and convening the global community for constructive dialogue and consensus building. As you know, in 2016, FAO convened the International Symposium on the Role of Agricultural Biotechnologies in Sustainable Food System and Nutrition at FAO headquarters. One of its key messages of that symposium was that the enormous potential of new gene editing technologies and the need to follow closely their advancements were acknowledged. FAO has just set forth its new strategic framework for the next decade that seeks to support the 2030 agenda with the transformation to more efficient, inclusive, resilient, and sustainable agri-food system for better production, better nutrition, better environment, and a better life, leaving no one behind. It is important to note that while new technologies can be enablers, these can also lead to a technological divide impacting small-scale producers who, due to the high initial investment cost and need for training and education, might not have immediate access to the benefit of the technology. And this is why FAO recognized that new genomic techniques are rapidly evolving and warrant a harmonized regulatory approach. As you may know, FAO has recently created the Office of the Chief Scientist. In fact, I'm just 6 months into my tenure as the first Chief Scientist of FAO. Complementary to this is the establishment of the Office of Innovation, again, for the first time. All these steps were taken in order to enhance FAO ability to convene the global community on such topical issues as the NTGs, which could aid our quest for a hunger-free world. FAO upcoming Global Conference on Seeds, the pre-summit of the United Food Systems Summit, the Science Days of the United Food Systems Summit in July, and the Food Systems Summit itself in September, all provide a global platform for presenting and debating science. Ladies and gentlemen, the joint FAO-IAAA Center provides technical support to members for crop improvement using plant mutation breeding. This method has a long and proven history in the development of many cultivated crop varieties worldwide. Plant mutation breeding speeds up the process of spontaneous mutation naturally occurring in plants. It is a technology that is simple and accessible for use in developing countries. This joint center is currently seeking to establish a CRISPR-Cas system as a functional genomic tool for gene discovery and to provide technical capacity building for those members seeking its use for crop improvement within their regulatory framework. In closing, I firmly believe that to be able to reach impact at scale, we must develop new and transformative partnerships. This includes working with the private sector and the civil society organization to ensure that together we end hunger and leave no one behind. Thank you very much for your attention.
So we had the opportunity to listen to the views and the messages of FAO. And again, thank you for the presentation by video of Dr. Ismahane Elouafi. And now to complete our worldview, I would like to turn to Dr. Khayat. Dr. Khayat is now the scientific director of Rahan Meristem. Rahan Meristem is an Israeli company on plant breeding and propagation. And he was also a former professor of plant biotechnology in Israel. Dr. Khayat, you have the floor.
So thank you very much. I hope everybody can hear me. Is my sound okay?
Yes, absolutely. Please go ahead.
Okay, thank you very much. So first, I would like to thank Farm Europe for inviting me to this very interesting meeting. And I will present, I hope it will be short enough, a case scenario that probably will reflect the importance of this technology. So, and I present it on behalf of Rahan Meristem, the company that I've been working on for the last 30 years. So we're talking about mitigating the major threats of the banana industry. And I will show these threats in my next slide. And we will be using precise genomic breeding techniques. And these are the genome editing is one of the techniques, especially with CRISPR-Cas technology. So this is a case scenario. But before I start with the case scenario, I just want to show that our business as Rahan Meristem is breeding and in vitro propagation and distribution of banana plants as a major product. We have additional product, but banana plants are the major product for Rahan Meristem. Can you see my presentation? Sorry. No?
Not yet.
1 second. Oh. Can you see now?
Yes.
Oh,
Yes.
okay. I apologize. My colleague here told me that I'm not able, yes, that I cannot see, that I'm not sure. Okay. So I will continue. I said that our business is both developing new product and distributing them after propagating in vitro. The company is spread throughout the world. Anywhere where bananas are produced, we are there. We have 5 different laboratories around the world, and we are going to build additional ones as we continue to increase in size. So now I will tell you about the case scenario. So that in banana industry, there are 2 main threats in the production. One is a disease that is called Panama disease of Fusarium that received a lot of attention in the press in the last few years. And the second one is black sigatoka disease that by far is probably one of the most devastating diseases and one of the most expensive diseases that exist worldwide. So if I compare the two, the Panama disease, there are actually no practical treatments to this disease. So a field or plantation that is infested by Panama disease will be uprooted, and the grower will have to either stop producing bananas or move to another section. While the black sigatoka disease, there are treatments, but the treatments are very expensive. They're not affordable to third world countries. And they are also very restricted due to regulations in many countries. The symptoms on the Panama disease it's a wilt disease, while on the black sigatoka disease, it is a leaf necrosis disease and early fruit ripening. Both of these diseases are major threats to the banana industry. So here at Rahan, we handle the Panama disease simply by mutagenesis. We induce mutagenesis in vitro, and we have already products that are completely resistant to the disease. While on the other disease, the black sigatoka disease, we're using the NBT or genome editing using the CRISPR-Cas technology, which I will describe. So now I will focus on the black sigatoka disease, and I will show that really the pathogen has a big advantage over the plant. The plant is seedless, so it's sterile, so there is no diversity in the plant. And as breeders, of course, we need diversity, otherwise we cannot breed. The plant is also a triploid, which creates a different problem. So there is a ploidy issue, and there is a monocarpic characteristic to the plant. The pathogen, on the other hand, has a very quick turnover through 2 types of spores, ascospores and conidiaspores, that are created by the pathogen very quickly. And so the pathogen is evolving very quickly to overcome resistance that the plant has developed back before it became sterile. This is a photo that shows the necrotic areas of the leaves in the plant, and these are caused by the mycelium of the pathogen, and we can overcome this problem by stopping the process that is creating this death, that actually the plant activates this death as a technique or to overcome the pathogen. So it's a defense technique. So the plant commits suicide to defend itself. So the strategy that we are using is stopping or reducing the hypersensitive cell death, okay, that are activated by the plant itself. And so by doing so, the fungus will shift from a necrotrophic fungus to a biotrophic fungus. And this will create a system where the plant can slow down by far the progression of the pathogen. So there are a few questions that need to be asked before we started the project. Are there relevant gene variations within the banana gene pool that can be used, if we can use genes that will create the resistance in the Musa genome? And how can we increase the probability of finding these genes? And the third question is, how can we identify relevant genes? How can these candidate genes be identified? So we have identified genes, and we use the GMO technology just as a precursing technology in order to see if it's even possible. So all of these lines, the data here shows different plants with different constructs, with different genes, showing that the red line is the control plant, and the blue lines are either above the control or below the control. And you can see that on the indexing system that we are using, we have some plants that give excellent results, that actually the plant does not have to be treated whatsoever. It doesn't have to be sprayed at all. So that was on the GMO technology. Now we're moving using the same genes. Since it's a knockout technique, we're using the same gene with the CRISPR-Cas technology to knock out even more efficiently. But more importantly, we are targeting very specifically the locus on the genome where we are doing the modification. We're not adding genes from the outside. We are just modifying the genome very specifically and very precisely to not just the gene that is the candidate gene for that confers the resistance, but also the precise area in the gene. So in order to do this, we need to gather a bunch of tools that need to be created and adjusted for the species that we are dealing with. And especially for bananas, it's very difficult to do this. So we actually now we're in a position where we have all the tools in our toolbox in order to perform these resistant lines. And on the time scale, we are somewhere over here where we already identified the genes, and we did most of the constructs are already in the plants, and we are ready to take the plants to the field for field trials in order to see if the same results that were achieved in the field from the GMO technology will be achieved now by using this new technique. And here I stop, and if you have questions, I'm happy to answer. I would just say that Black Sigatoka disease causes the farmers in Latin America in the range of about $2.5 billion a year. And it entails something like between 20 to 60 sprays a year, very heavily sprayed crop. Thank you very much.
Thank you. Thank you, Dr. Khayat, for sharing with us the case study on bananas and reminding us the world importance of banana production. And it's all the more interesting to me because when I was an official in the European Commission, for a number of years, I dealt with bananas. and the worldwide implications of trade in bananas. So that was a very interesting rappel, if I may say so. Dr. Khayat, we will have perhaps questions at the end. If you allow me, we'll move now to the last group of panelists, and to Professor Dr. Klaus-Dieter Jany. Now we are going to talk about science and science presentation. Dr. Jany is the chairman of the German Scientific Association for Gene Engineering, and formerly he was the director for the Molecular Biology Center of the Federal Research Institute for Nutrition and Food, amongst other roles that he had. Dr. Jany, can I pass you the floor?
Yes, of course. I will start. Again, thank you to Farm Europe for organizing and hosting this webinar and for inviting me to speak here. I would like also to say thank you to the Commission, and in particular to its staff, and of course to Dr. Jülicher for the comprehensive, and that's very essential for me, objective report on the status of the new genomic techniques. Many things are said before, therefore I will shorten very much my talk. We, the society or humanity, are facing enormous global challenges: pandemic control, climate change, loss of biodiversity, limited natural resources, growing world population, securing food supply, and the later should be achieved with less and less arable land and increasing requirements in respect to sustainability. And that's not only about the food supply, but it's also about food safety. And all these things should be guaranteed with sufficient earning for the farmers and without major financial burden on consumers or to the public. Nearly an unsolvable problem. This problem wants to solve or to tackle the Commission with the Green Deal and the Farm to Fork strategy. Europe, of course, and in particularly agriculture and food production should become climate neutral and sustainable. In this part, research on this area and the implementation of the research results are more than necessary. Indeed, much research is being carried out in Europe, even excellent research work, but their results are often disregarded or even ignored by the public, often also by the politician. And in addition, there are high hurdles in implementation the results to practical innovation, especially in the modern food biotechnology. Far too seldom, research results lead or arise in real innovations that can be also implemented economically in the sense of sustainability. Far too often, these arise from China, USA, and now from Great Britain, using European research results. Often was said, we need a new regulation. That's true. And why we need a new regulation? Our genetic gene engineering legislation is mainly based on the scientific and technological knowledge of the 18th or 19th of the last century. The revision of the old directive dated from 1919 in 2001 has not much changed. It was more editorial changes. And of course, the new directive for liberate release is one of the few laws in which it does not provide for adoption on scientific or technological progress. That's really surprising. And of course, we have learned so much in the last 20 to 30 years about gene technology, GMOs, the influence on health, environment, and also all other things. Yes, the reform of the old genetic engineering legislation is long overdone. It should reflect now the current state of science and technology, that was also said by Dr. Jülicher. On the other hand, it was also said before, these new techniques have a wide range of application. It can cause point mutation, insertion, deletion of individual small nucleotides, or lead to larger genomic changes, such the insertion of species-specific or foreign gene. So specific genes, that means, but also said before, cisgenesis. Due to these different possibilities, a blanket legal definition is not meaningful. A differentiation between the different techniques and the resulting plants is necessary. Otherwise, genetically identical plants, but bred using different methods, would have been classified and regulated differently. The classification of a GMO or an organism which might be excluded from the regulation should be made by a case-by-case decision. Such a process means also weighting up the positive and the negative effects. That means, of course, a risk assessment. And the precautionary principle must not be linked to speculative risk, but must be applied on a basic of science, as it was also acknowledged by the European Court of Justice. Of course, failure to adopt gene legislation will have permanent disadvantages for research, plant breeding, agriculture, and global agriculture trade. First part in science, very short. We will have a massive loss of know-how in applied sciences and, of course, in breeding. And on the other side, young, very excellent trained scientists will leave Europe because they do not see any development opportunities in Europe. You know it a long time before the word brain drop. Agriculture, yes, we need new plants, but breeding is a time-consuming process, and we need these new plants in a timely manner. The new techniques opens opportunities. They have the potential to breed climate resilient plants, to reduce the input like water, fertilizer, plant protection products, and so on, to reduce the emission of greenhouse gases, to maintain or even to increase the crop yields, increase of the output per unit of arable land. Altogether, with these techniques, we can protect biodiversity, but also we can save local varieties and orphan species. Of course, in the moment, only a few plants derived from these new techniques are on the market, but more than 200 will be on the market in the near future. The goals of the plant breeders or the scientists are not just promises. We should use these opportunities to achieve the sustainable goals. Trade, that's a special part that depends a little bit about identification and labeling, and it is not easy or even impossible to clearly differentiate if the genetic modification derives from the new techniques or to a national mutation. And therefore, if we do not change something in this case, there will be a distortion in the international trade, and the EU will hardly be able to participate any longer in an international trade flow for foods and feeds. Of course, one should not only demand or argue why the legal regulation should adapt to the state of science and technology, but one must then also make suggestion for an amendment how such a change could look like and how new plants can be classified or regulated according to the different application procedures. In the following part, my colleague George will present a proposal. So I or our organization can only encourage the Commission to make also suggestion and open the discussion, a clear discussion with all stakeholders in time to achieve a vision. Without proposals, we cannot really discuss what we had to do. And at the end, the Commission has quite rightly recognized we are responsible both for what we are doing and for what we refrain from doing. Thank you.
Thank you, Dr. Jany. And now we'll have a follow-up on your intervention from Dr. Georges Freyssinet. You are now the president of the French Plant Biotechnology Association, and you were also a university professor and very active in the private sector, several joint ventures in the biotech sector. So, Dr. Freyssinet, you have the floor, please.
Okay, good afternoon. First, I would like to thank Farmer for giving me the opportunity to present our proposal for adapting the GMO regulation to plant derived from NGTs. As said by Klaus, Jany, and other speakers, it is critical for Europe to be able to use this technology available in order to improve crop. And not only this one, but all technology which are available. Among this technology, I would say that new genomic technique will play an important role at a time we have to reduce the use of pesticide and to have crop able to stand changing climatic conditions. They are also critical to help achieving the goal of the Green Deal and the Farm to Fork project in Europe, which have been presented previously. We also heard from Mr. Haniotis the goal and challenges for agriculture and the need for science, and from Mrs. Jülicher the main conclusion of the studies published by the Commission. This report from the Commission indicates that new genomic techniques show potential for sustainable agriculture and that there are strong indications that the current GMO legislation is not fit for purpose for some NGTs and their product, and that it needs adaptation to scientific and technological progress. And the Commission planned to initiate a politic action on these plants produced by targeted mutagenesis and seed genesis. The AFBV in France and WGG in Germany agree with this finding. And in fact, we have been working on this subject for several years, which has resulted in a proposal sent to the Commission and the French and German ministry in February last year. And I will quickly summarize this proposal. This proposal has two main components. One is the establishment of category of edited plant, which should be excluded from the scope of GMO legislation, and the second, the validation process. Let's go first to the establishment of category. As it has been told, editing technology can be used to obtain a broad range of modification in the genome, going from a change in one nucleotide up to incorporation of whole gene. And we are proposing to establish category of plant based on the type of edition that has been obtained. As a first step, we have defined 4 categories, which will appear later on the slide, which is on the screen. 3 for edited plant and 1 corresponding to cisgenesis. I will use the term edited plant in the rest of the presentation to cover the 4 categories. New category may be added later with the evolution of scientific knowledge and technology for regular update of the legislation. And this category we establish, to establish this category, we took into account the approaches which are used by plant breeder. And the main reason for that is that many analysis and evaluation of this technology undertaken by several organizations, among which the EFSA and the SAM, have concluded that plants developed with the use of such technology are no different in their effect on health and on the environment from those obtained from traditional breeding method. Before describing the category, I just want to remind you that editing is always performed on a gene which is present in the genome of a receiving plant. And the different forms of the same gene are called allele. So the editing process, when we do that, we are changing the allele present of a gene present in the receiving plant to an allele of the same gene with a different function. And the category, I will now describe the 4 categories, and due to time constraint, I will give you only 1 example per category, but remember that there are several which can be found in the literature and or in the field in certain countries. For category 1, it corresponds to a plant edited to reproduce a trait existing in another plant of the same species, sexually compatible. This is equivalent to what the breeder is doing when he crosses a wild plant with a sexually compatible cultivated variety. And the soybean with a high oleic acid content, which is on sale in the US, belong to this category. The second category, if you can click on the slide, it should appear, is an extension of category 1 to gene shared by the cultivated species and another plant, which is not sexually compatible. And this has been done to introduce virus resistance in tomato, using as a model the allele present in pepper, which is resistant to this virus. The category 3, next if you click, category 3 corresponds to a plant with a novel trait for the species, but the changes could have been obtained through the use of conventional random mutagenesis, followed by selection of a mutation or to obtain the desired trait. This is the case of the GABA tomato under launching in Japan. And if you compare this edition to the random mutagenesis, remember that you can do the addition only if you have enough information and knowledge on the allele, which will give you the trait. So you're not going at random, you are going at a very specific step. The last category corresponds to plant in which a known gene present in the natural gene pool of that species has been inserted into the genome of a receiving plant. And this is equivalent to what is named cisgenesis in the Commission study report. And this has been done, for instance, in tomato to obtain mildew resistance by introducing several genes from wild potato to cultivated potatoes. If you can remove the slide now, if Mr. Boila, thank you. It should be noted that in one plant, different genes can be edited or introduced, to modify one trait. This is often the case for when you want strong disease resistance, or you can edit several traits or introduce several genes in one plant. And this is done, for instance, if you want to stack disease resistance and quality trait. And category is then determined for each gene if each gene edited in the plant. As said previously, the edit plant belonging to one of these four categories should be excluded from the scope of the GMO legislation, as are plants obtained from technologies such as mutagenesis, described in Annex 1B of the 2001/18 directive. And this adaptation can be done through minor changes in the directive. Since genome editing technology cannot be excluded as such, we cannot use Annex 1B. We are proposing to add one Annex 1C to the directive, which will describe the category. So we can add category to this annex as the new category appear. And the validation process I will explain you later. We will probably need to make a small addition to the directive to introduce this annex. Finally, since we are considering the nature of a final product, this approach is valid whatever the edition technology you use, whether it is SDN1, SDN2, using CRISPR, TALEN, meganuclease, ODN, or primate or base editor. It does not matter if it also will be usable, this approach, if new technology are developed. I will go and finish by going very quickly to the validation process. In order to maintain trust in the editing or cisgenic plant, we are proposing a process for a competent authority to validate that the edited plant belongs to one of the four categories. In its request, the notifier must provide information on the recipient plant, the technique used, the edited plant or the inserted gene. In the case an intermediate GMO was produced for the editing process, any inserted or recombinant nucleic acid sequence should be eliminated, and confirmation of the elimination should be provided. The exclusion of an edited plant will apply to all varieties obtained from that edited plant with the same modification, and will apply to all member states. It will be good if a review time can be done in 60 days. Once the confirmation of exclusion has been obtained, the variety or varieties obtained using the edited plant will be subject to the seed and plant variety regulation applicable to relevant crop species, as for any variety obtained through traditional breeding technique, including registration in common catalog of variety of agricultural plant and vegetable species, which can be marketed in Europe, as well as the labeling and traceability rule which apply to these varieties. There may be need to adapt this labeling and traceability to take into account the specificity of edited varieties. Thank you for your attention.
Thank you, Dr. Freyssinet. And we have come now to the end of the presentation of the panelists. And moving to the questions and answers, I have here two questions that I'm going to read. First is for you, Dr. Khayat, and it's the following. Can you clarify if the work done by your firm, Rahan Meristem, on the black Sigatoka banana disease is of the same nature as the classic selection techniques by mutagenesis, but with faster and more precise results?
Yes, I can answer this question. By simple mutagenesis, people have tried to get a mutation that will confer resistance to black Sigatoka disease in the last 40 years. And nothing panned out. So I'm not saying that it's not possible, but until now, nobody succeeded.
Very clear. Thank you, Dr. Khayat. I have another question for you. And I think this one also, I would like to hear the response from Dr. Jülicher. The question is the following. Is it possible to detect whether an imported product comes from classical mutagenesis or from a new genomic technique? Dr. Khayat, what's your answer to that?
So theoretically, it is possible if you perform a whole genome sequence, okay? But that's on the theory. In reality, there are many changes that occur in the genome that are much more extensive than the results of using NBT of any kind, or especially CRISPR technology, especially if it's a knockout technique. So in principle, I think that it is possible, but only if the breeder would direct the regulator to tell him what did he do. If the breeder does not cooperate with the regulator, in my opinion, it's completely impossible to detect the change and say that the change was created due to NBT or some kind of a CRISPR-Cas technology or something like that. That's my response.
Thank you, Dr. Khayat. Dr. Jülicher, this is an important point for consideration for us in the European Union, I believe. What is your, what would be your response to this question?
Yeah, thank you very much. I mean, on the scientific side, I mean, Professor Khayat is much more better placed to explain, and I think he explained very well. From the let's face it, this question was one of the drivers also for the Council to request the study from the European Commission, because they have indeed issues around enforcement and implementation of the court judgment, and there was implementation of the GMO legislation. Now, in a bit more context, obviously, currently, very clear, a product that falls under the GMO legislation, including those derived from new breeding techniques and qualifying for the GMO legislation, for the time being, has to obtain an authorization. So, I mean, there is more around the system than just, you know, authorities going and trying to use methods to detect maybe a product that was developed with new breeding techniques. So we have a system where everybody carries responsibility. So the breeder who wishes to introduce such a product in Europe carries the responsibility to obtain an authorization under the GMO legislation these days. And that will also imply that the authorities will learn about, you know, the details of the modification of the genome, they will also be supplied with a detection method. Should we, however, have, and we have no indication that this is happening, importers or plant breeders that wish not to follow the European regulatory framework, I think then the answer of Dr. Khayat fully applies. Without knowing what is behind, without having this relation with the breeder, currently it is next to impossible to detect such a modification. And that's why we also need, to work further on this. And we have also, as Commission, asked our laboratory network to continue working on this. But bottom line, it is challenging. But in the end, we have a much broader system than just going out and analyzing products. Thank you.
Thank you, Dr. Jülicher. We are running out of time. I have other questions, but I have perhaps to select perhaps one final question to you, Dr. Jülicher, if I may. The question is, what is the expected timeline from your perspective for us to see policy action, as you mentioned, from the Commission?
Yeah, I mean, as we communicated, we are now really engaging with many parties, on the basis of this study. We want to follow for this initiative, as for any other, what we call better regulation principles. So this will mean that we will come up with an inception impact assessment, which outlines a bit, what is proposed. And we have no firm timeline because we think this exchange is extremely important, but the timeline we have in our mind is somewhere third quarter of this year, when we start, with a more formal process. That will not yet be a proposal, by far not, but we will start the process that could possibly lead to a proposal around that time. So third quarter, I would say, is more or less appropriate. It depends a lot on the discussion. It depends a lot on the reception. And as I said, in this context, it's very interesting, the discussion we have heard from the ministers responsible for agriculture yesterday, and the same also the exchanges that the Commission has with the Parliament, for example, but also other stakeholders. Thank you.
Thank you. If we can be of any help, please let us know. We are running out of time, so I have, unfortunately, to wrap up the seminar. Let me try to summarize very briefly what we heard, which is close to impossible. But we heard on the political side that environmental goals are extremely important, but we have to look also at the economic profitability for European farmers, for European agriculture. And we have to look on how these new techniques can help protecting farmers from climatic events, increasing their profitability, and contributing to fulfill the environmental and climatic goals. We also heard a very good summary of the conclusions and the detail of the Commission landmark study. I take that it has been found that these NGTs can contribute to the Green Deal goals, to the Farm to Fork goals, to the Sustainable Development Goals of the United Nations. And although there are concerns that were highlighted, EFSA concluded that in safety terms, they are similar to conventional techniques. So an important conclusion is that the existing GMO legislation is not fit for these new techniques. And again, we will see, as described, policy action ahead by the Commission. From the agricultural side, there was a huge emphasis on how these techniques can reduce costs and finally produce more using less inputs, and that is extremely important for the environment and for farmers and their economy. From the FAO, we heard about examples of positive impacts of NGTs and a plea, I would say, and an offer from the FAO, a plea that we take measures based on scientific evidence, and an offer from the FAO to work towards world consensus on these issues that would enormously facilitate the implementation of these techniques and their acceptance. We heard also in detail the case scenario of bananas and what we can take from that. Bananas are a very important staple around the world, and this technique provides a unique opportunity to address a threat to the continuation of banana production, and that was extremely interesting. And then we heard about the scientific views from the European side, and the fact that it's so important to have the state of science be reflected on European Union regulations, and to keep our scientists in the EU and not have them, as also Mr. Haniotis said, immigrating to other parts of the world to continue to use their knowledge on these issues to the benefit of others and not European Union population. We heard also on the potential of these techniques to reduce inputs, reduce greenhouse gas emissions, increase productivity. And we heard also on the detailed proposal from the scientific community that expressed their views here in this webinar today in both Germany and France on what should be done to allow a proper regulation of these techniques. Of course, I cannot summarize everything, but that was my take on the most relevant points. And let me now come to the end of this webinar by thanking all of you, thanking first our panelists, and thanking also all the attendants to the seminar. Thank you and goodbye now.
Bye.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.
Bye.